we definitely find with that one for the totally blind students, they tend to focus on the tactile feel, but that also kind of correlates with how we normally organize the galaxies based on shape as well. So that's kind of interesting.
Hello, and welcome back to Physics Chat, the series where we talk to physicists about their life and research. Today I'm joined by my co-hosts Sergi and Dan, but also our guest Nic Bonne, a public engagement and outreach fellow at the Institute of Cosmology and Gravitation. He is the lead on Tactile Universe, which aims to increase the accessibility of astronomy to blind and visually impaired people. Stay until the end for an announcement where you can watch us live. It's not exciting. But back to Nic. When did you become interested in astronomy?
So I think I first became really interested in astronomy when I was 5, believe it or not, so quite young. I remember there was a documentary on TV about the Voyager space probes. And so Voyager 1 and Voyager 2 were these probes that NASA sent to basically take pictures of the gas giants in our solar system, so Jupiter, Saturn, Uranus, and Neptune. And they sent back just these beautiful detailed images, some of the best images we had at the time of those planets and also of their moons. And I remember I was sitting with my head pressed right up against the TV screen so that I could sort of see what was going on. There was this picture of Neptune, and I just remember seeing that and seeing how beautiful it was this beautiful deep sort of blue color. But also, I guess I noticed just how empty the space behind Neptune was. How dark it was, how empty it was. And I guess 5-year-old me started thinking, wow, space is really big. Space is really empty. There's a lot of space between everything in space. And I guess that got me thinking about astronomy, about space science, about all of those other kinds of things like that. And yeah, from that moment on, I was just kind of hooked. Anything I could find to learn more about the solar system, learn more about space, learn more about galaxies. I read a lot. I watched a lot of TV. I talked to people. Every time we went for a family camping trip when I was growing up in Australia, we'd find a little sort of amateur, I guess, observatory, and we'd go to stargazing nights. And yeah, it was just this almost obsession with space from quite a young age.
Yeah, that's amazing. So you started this journey very, very young and still continue it today. So could you briefly describe what you research for your PhD?
I actually had two tries at a PhD. I did the normal thing, and I did my university degree. I studied lots of physics, lots of maths, a little bit of astronomy. Then I actually started a PhD where I was studying galaxies in the local volume. So the local volume is just a little bit of the universe around us with sort of a handful of galaxies in it. And I was using a combination of radio and optical data to look at rotation curves for these objects to try and work out how the dark matter inside them was distributed. So basically looking at the way that these galaxies were rotating and then working out where the missing mass was, where this dark matter inside these galaxies must be. So I actually got about 2.5 years into that PhD, and I ended up quitting because I was getting really stressed. I was quite depressed. I was having a lot of sort of mental health issues. And so I actually walked away from my PhD at that stage, and I thought, I wasn't actually going to keep going, that maybe that was the end. I wasn't going to be an astronomer anymore. It took me a couple of years. I got help. I understood myself a lot better. I sort of sorted out all of the mental health issues that I was having. And then I actually met somebody from my old university where I'd done my undergraduate degree. And they sort of said, would you like to come back and have another shot? Would you like to have another go at a PhD? And so I said, yeah, sure, I'll give that another go. I studied galaxies again. This time around, though, I studied these things called luminosity functions. Luminosity functions are plots where on the horizontal axis is the magnitude of galaxies, so basically how bright they are. On the vertical axis is the number density, so basically how many galaxies we see in a particular region of space. So these plots are a really good way of looking at galaxy populations, understanding how they populate space, but also where we're likely to see galaxies that are brighter or galaxies that are dimmer. I studied luminosity functions in lots of different wavelengths. I also broke the functions up based on what kinds of shapes galaxies were and also what kinds of optical colors galaxies were, so whether they were blue or whether they were red. So yeah, it was a really interesting PhD to do. I got to play around with lots of really interesting data. A lot of my initial work was literally building a catalog from lots and lots and lots and lots of different data sources and trying to make that as complete as I possibly could. For me, that was a good project because I was able to play around with the data and not have to rely on the visual too much. But there were points where I sort of ran into issues, I guess. So even though I had numbers for all of my galaxies, even for their shapes, I had sort of number designations that told me what these galaxies should look like. I sometimes had to look at the actual images of these galaxies, the telescope images, to make sure that the numbers were actually telling me the right thing, that if I thought this was a spiral, that it was actually a spiral based on what the image looked like. And so that was where I struggled a little bit, actually looking at these images, working out whether they were correct or not. And yeah, that's actually sort of led into the work that I'm doing now.
Yeah, so as you said, astronomy is a science that relies a lot on images and the visual aspect of it. Like, as you were saying, we study galaxies mostly by looking at their shape and their color. Could you share with us how having a visual impairment affected your experience throughout?
Obviously, it hasn't been a particularly easy journey. I think I've been really lucky in that even when I was 5 and I said, I want to be an astronomer, nobody said, no, you can't do that because you're going to find it too difficult. And that definitely does happen to some young people. They might have some kind of impairment. They say they want to do something, and somebody will often say, look, you really shouldn't do that. It's going to be too hard for you. And they're never doing that because they're being mean. They're doing that because they're trying to save that person from experiencing something difficult or something painful. You can sort of take that whichever way you want to, I guess. Even sort of going through school, learning science, I couldn't always do exactly what my classmates were doing. But I was lucky in that I had some really passionate teachers who were willing to spend that little bit of extra time, sit down with me, work out alternative ways for me to access things, whether that was just making things bigger, making things higher contrast, or finding a different way for me to do my lab classes so that I could be a little bit more tactile rather than having to do sort of overly visual stuff. That sort of continued into university as well. I think I was really lucky in my undergraduate degree that there were 1 or 2 of my lecturers who really, really wanted to see me succeed. And so they spent that little bit of extra time making sure that I had what I needed to succeed. That's, again, everything from producing tactile versions of diagrams to making sure that I could record my lectures so that if I couldn't quite keep up with note taking, I could go back sort of in the evenings and finish taking all those notes so that I could sort of keep up with things. When it came to my PhD work, so if you've ever sort of seen the average sort of astronomy plot, the average thing that people publish when they write a paper, oftentimes they're not particularly easy to see. The text is really small. Color contrast isn't great. People aren't always good at making sure that all of their different data points are easy to distinguish from each other. I started off making plots like that as well. And it actually took one of my supervisors going, Nick, can you actually see the plots that you're making? And I said, no, but I assume everybody else can. And they said, well, why don't you make them so you can see them as well? And then it's probably going to be easier for everybody else as well. And so I started making plots with really big labels, really bright colors, really distinct symbols. It felt a bit weird because it was very different from what everybody else around me was doing. But yeah, it actually ended up, I ended up producing things that I could see, things that I could interpret. And it actually made my work a lot easier. When it came to looking at those images, though, sort of those images of galaxies, that was still quite difficult for me. So oftentimes I'd have to turn to one of my office mates and go, can you see some spiral arms there, or am I imagining or what I'm seeing? That was okay. But it did mean that I wasn't necessarily being as independent as I wanted to be about everything. So, and it also meant that I was relying on somebody else's interpretation of my images a lot of the time. So yeah, it's not always been easy, but I think I've been really lucky in that I've always had those people who are willing to step up and spend that little bit of extra time and be supportive and sort of, yeah, it's definitely been an interesting journey.
So you have helped also make this channel more accessible, for example, through the use of name tags and other things, for which we are very grateful. If we were giving a talk or a lecture, how could we make it better for a visually impaired person?
There are a couple of, I guess, really key things that you can do. So the biggest one is to make sure that you describe everything. So if you have a plot, if you have a picture, anything visual that you're relying on the audience seeing to understand what you're talking about, try to describe that as best that you can. So if you're talking about data points in the top left-hand corner of your plot, then literally say, and now we're talking about the top left-hand corner of our plot. So lots of little things like that. In terms of clutter on slides, that can be really difficult for people who are low vision or have, a little bit of trouble seeing. So really try to keep your presentations, your slides nice and clean. Don't put too much stuff up there. Make sure your text is big and easy to read. High contrast is really important as well. So it's actually not so great a lot of the time to have a really bright white background with dark text on top. So making that background a slightly off-white color can be a little bit better. Or flipping things around and doing something like, say, a dark blue with a maybe yellow or white text on top can be really good as well. Yeah, just high visibility, lots of audio descriptions can make a really, really big difference.
As we've mentioned previously, you now work in accessibility in astronomy through the Tactile Universe project. So could you tell us some more about that?
Yeah, so Tactile Universe is a project that we started back in 2016. So I joined the ICG in 2015 as a visiting PhD student. It was actually one of the academics here asked me the question, like, what would have made your PhD research easier for you to do? And my almost instant response was, well, if there was a way that I could have felt the images of galaxies that I was studying rather than having to look at them, that would have made, my life so much easier. It just so happened that one of our other staff members, Coleman, was in the office across the corridor from where I was having that conversation, and he overheard, and he had a little bit of experience making 3D models and basically went away. He found somebody with a 3D printer, 3D printed that model, brought it back to me and said, Nick, is this what you were talking about? And so that's sort of where the Tactile Universe started. We definitely started off very small, very local. We did a lot of work with a blind and vision impaired support organization that runs out of Southsea in Portsmouth. We worked with that group to sort of test a lot of our initial ideas for the kinds of tactile models that we wanted to make. But we also did a lot of work around the kinds of language that we were going to need to use to actually describe those models in ways that were going to work for an audience that was less visual. And then because that initial pilot was so successful, we were then lucky in that we applied for some money through the Science and Technology Facilities Council to basically start expanding the project to try and get it out to more people around the UK. And so, with that funding, we were able to produce resource kits. We were able to train other astronomers, other science communicators, other educators all across the UK, and basically give them resource kits so that they could use our resources to start engaging with blind and vision impaired people sort of local to them. At that point in time, we also changed the focus of the project a little bit to really start working with young people because we really believe that if we can engage students with accessible resources at that age, we can really make a difference for how they see science and how they see science as being accessible. So that's also sort of a really big focus of the project.
Amazing. Yeah, that's really interesting. We have actually had Coleman on before, although talking about citizen science, which is other projects he gets involved in. So the Tactile Universe, though, so what other astrophysical phenomena can we demonstrate with this method?
For the original set of resources we developed, we sort of made two educational modules where in the first one, we talk about the solar system. So that's sort of aimed at students in upper primary school. We talk about the sizes and the scales in the solar system. So we use a set of sort of commonplace objects, things like a peppercorn to represent the Earth, a tennis ball to represent Jupiter, a beach ball to represent the sun. We then run a workshop where we talk about galaxies, and that's where most of our sort of 3D printed resources come in. So we have these models. They're a tactile surface that represents the change in brightness in an image of a galaxy. Where the galaxy is brighter, the tactile features will be higher up. Where the galaxy image is dimmer, the tactile features will be a lot lower. So the idea is you can sort of run your fingertip along that surface and feel the shape of the galaxy, feel where it's bright, where it's dim. So we have a set of 10 different galaxies that we use. We get students to do their own classification exercise where they come up with their own way of classing galaxies. So that could be organizing them into things like spiral galaxies or elliptical galaxies. We definitely find with that one for the totally blind students, they tend to focus on the tactile feel, but that also kind of correlates with how we normally organize the galaxies based on shape as well. So that's kind of interesting. So real mix of sort of high tech and low tech stuff to engage with students. And then more recently, we've actually tackled gravitational waves. And you probably had some people come on in past seasons talk about gravitational wave research. But yeah, we do everything there from talking about compact objects, so things like black holes and neutron stars. But then we also have these beautiful tactile plates that represent two black holes spiraling in towards each other and sort of the gravitational waves rippling out from those. And we actually pair those with gravitational wave chirps. So the sonifications, the audio versions of those detected gravitational wave signals. But also, yeah, introducing that really multimodal sort of way of interpreting that. So making sure that there's a visual element, there's a tactile element, and there's an audio element. So giving people the chance to interact with that data, interact with that information in whichever way is going to be the best for them.
Okay, so you use 3D printing to get these amazing models. How do you then practically use them to teach astronomy?
We have a couple of different ways that we engage with people with these, I guess. So obviously we can take these out to things like science fairs. We run a big public event called Stargazing that I think we're going to talk about a little bit later on. But yeah, they're good for keeping people occupied. Basically, if you give somebody a tactile model to hold, even if they're not somebody who's visually impaired, we found at least that it's a lot easier to talk to people because you can sort of hold their attention for a little bit longer. In terms of sort of longer form stuff, like the kinds of stuff we do in schools, we have a couple of different ways that we can use the models. A lot of the vision impaired students in the UK are actually embedded in mainstream classrooms. So they might be the only vision impaired child in a classroom that's mostly full of students who are fully sighted. So if we can, we'll often try and run our workshops with that entire classroom. What we found is that really brings the students together. It gets the sighted students thinking about what kind of adaptations the vision impaired students might need to make to sort of access the same stuff that they're accessing. But it also encourages the fully sighted students to think about things in different ways and to sort of start using their other senses rather than just relying on their vision.
It's amazing to see how much and how quickly this project has grown. And hopefully it will continue to do so in the future. One thing that I'll also mention in case Nic doesn't is that this project has received several prizes. Do you want to tell us about that?
Sure. Yeah. No. We we have got. You're embarrassing me now. We have gotten a number of awards. Actually, last year we were really honoured to receive a medal from the Royal Astronomical Society for the work that we've done. It was one of the Outreach Awards. I think we do this project because we love it, but we also want to make a difference for young people who are blind and vision impaired. Obviously, I have a pretty big personal stake in this project as well. Yeah, we are just so excited, so honored that so many people think that this project is worthwhile, and so many people are excited about using our resources, excited about the work that we're doing, and that they see the value in what we're doing. And yeah, we really do think that we can make a big difference. We can change the way that people think about astronomy, start to shift away from the really, really visual view that we have of how astronomy has to work and how it has to, how we communicate astronomy, everything else like that.
Thank you for sharing that wisdom. That's really, really helpful. And you've talked at length about your scientific interests as well, which has all been fascinating. But on Physics Chat, we like to get to know our guests on a personal level too. You shared with us that you quite enjoy building and painting Warhammer miniatures. Just wondering, what was the first Warhammer miniature you ever painted?
So yeah, I play the science fiction version of Warhammer called Warhammer 40,000. My favorite army is so it's an army called the Black Templar, and so they're these super zealous crusading space knights basically. And the very first miniature I ever painted was one called the Emperor's Champion. So he's kind of what it says on the box, really. He's a really dynamic character, really dynamic pose. He's sort of standing with 1 foot forward. He has this giant sword and he's sort of holding it up into the air. He's got these sort of flowing robes. There's lots of sort of Crusader style iconography. I really loved painting that miniature because it was just such a dynamic one. Because he had these big flowing robes, I was able to do some really cool stuff there to make those look a little bit more 3D. But yeah, really fun model to paint, really fun model to play with as well.
It's really cool.
Wow, that's really interesting. But thank you for talking with us today about accessibility in astronomy and all the amazing work you're doing to help visually impaired and blind people. As Nic mentioned earlier, there is a public event called Portsmouth Stargazing, which is happening on the 31st of January. And it's a lovely event where you can come and learn about the research in the Institute of Cosmology and Gravitation. We're doing a live event, so if you want to see us live and you're near Portsmouth, come check us out. And you can even do some face painting if you fancy that. It's for all ages. But yeah, we'd love to see you there. Please join us again next time where we'll be talking to more academics about their research and their life. Bye. Bye.
We do this project because we love it, but we also want to make a difference for young people who are blind and vision impaired.